Have you ever noticed the same Spark job sometimes runs very fast and sometimes becomes very slow or even fails? And the strange part is your code is exactly the same. So what is actually changing? Not the code, not the data. The answer is memory. Today, we will understand how Spark uses memory and why it directly affects performance. Spark is fast because it processes data in memory. If the data stays in memory, everything is quick and smooth. But if memory is not enough, Spark moves data to disk. And the moment Spark touches disk, performance starts slowing down. Think of it like this. If everything you need is on your desk, you work fast. But if you have to go to another room again and again, your work slows down. In Spark, disk is that another room. Now let's understand how Spark organizes memory. Each executor, which is like a worker, has a limited amount of memory. And Spark divides this memory into two main parts: execution memory and storage memory. And almost everything Spark does happens inside these two. First, execution memory. This is where the real processing happens. When Spark performs operations like join, shuffle, sort, or aggregation, it uses execution memory. You can think of it like rough workspace. When you solve a problem, you write, erase, and rewrite. That temporary working area is execution memory. Now, storage memory. This is used to store data, so Spark can reuse it later. For example, when you cache or persist data. Instead of recomputing everything again, Spark simply reuses stored data, which saves both time and computation. Think of it like saving your work in a notebook. So next time, you don't start from zero. Now let's see what the problem was earlier. In older versions of Spark, memory was divided into fixed parts. Execution had its own fixed space. Storage had its own fixed space. Now imagine this situation. Execution memory is full. Storage memory is empty. But still, execution cannot use storage memory. And in another case, storage is full. Execution is empty. Still, they cannot share. So memory is available but cannot be used. So the real problem was not lack of memory. The real problem was fixed memory design. This leads to memory waste, more disk usage, and slow jobs. So Spark solved this problem. It introduced something called the Unified Memory Manager. And now execution and storage share the same memory pool. Memory is no longer fixed. It becomes flexible. If execution needs more memory, it can take more. If storage needs more, it can take more. Same memory, but much smarter usage. This sharing is dynamic. It keeps changing based on need. Imagine two teams sharing one room. If one team grows, it takes more space. If it shrinks, it gives space back. That's exactly how Spark memory behaves internally. But there is one important rule. Execution memory has higher priority. If execution needs memory, it can remove data from storage. But storage cannot remove execution data, because Spark always prioritizes doing the work first. Now, one important thing many people miss: not all memory is just execution and storage. There are other parts also, like user memory and reserve memory, which means total memory is not fully usable. You can think of it like an iceberg. What you see is only part of it. A lot of memory is hidden underneath. And even though you cannot directly see it, it still affects performance. So what happens when memory becomes full? Execution data is moved to disk, and storage data may be removed. And as we discussed, disk is always slower. So the moment data moves to disk, Spark performance starts dropping. Let's connect everything with a simple example. You load data, you cache it, then you run a join. Now execution needs more memory. So Spark removes cached data and continues processing. This is Spark dynamically managing memory in real time. So let's quickly recap. Execution memory is for processing. Storage memory is for saving data. Unified memory makes it flexible. execution has higher priority. And when memory is full, data moves to disk. And that directly affects Spark performance. So next time your Spark job is slow, don't immediately blame your code. Don't even blame the data first. First, check how memory is being used. Because in Spark, memory is performance.